Why do we need to program in a high-level programming language like C? On this slide, I'm showing you how you can print the message "Hello World" out on a computer that uses an architecture based on the Intel x86 chip and running a DOS operating system. And here I'm showing you how this happens for a computer that's running the same architecture but the Linux operating system. And you can see that the significant differences between both these pieces of code that are actually meant to do the exact same thing. So this is not good. I don't want to have to write a program from scratch every time I change my computer or every time I change my operating system. So the whole point of programming is that we want to write programs that are easy for us to write and understand, and that are easy to port to different types of computer hardware without having to rewrite the code. And both of these objectives are very important in real life. So high-level programming languages like C make it possible by writing the code in a high-level language and then translating it into machine language using another piece of code, which we call a compiler. So we write the program in C language, which we understand well, and then the compiler translates this code into equivalent machine language for that particular hardware and for that particular operating system. So those two pieces of code that I showed you right before these slides, those would both be automatically written by the compiler if you give the compiler a correctly written program in the C language. So this is the abstraction that a high-level programming language provides you. It allows you to write code in a language that is meaningful to us very simply, and then it enables us to write machine-level instructions using the information that we presented in the high-level language into a low-level language. So if you look at this low-level piece of code and you look at this high-level piece of code, you can clearly see there's a big difference in comprehensibility. What is this program doing? So we haven't actually looked at most of these terms that we are seeing here, but I'll just tell you that logically what this program is doing is while n, which is some number, is greater than 0, it repeatedly operates in this loop saying add n to this variable sum. So if sum started off as 0 and n started off as 10, then sum becomes 0 plus 10, and then you do this minus minus basically means subtraction. So you do subtraction of 1 from n, and so n becomes 9, and then we do this again because the while condition is going to be true as long as n is greater than 0. And then finally, when n becomes 0, then no more operations happen and we move out of this program. And so you add 10, 9, 8, 7, all of them to this entity. So it keeps a running tally of all the numbers counting down from 10 to 0, so that at the end of the day, you get 55 as your output. Now that we can look at this code and we can make sense of it immediately. It's also possible to make sense of that same logic here, but it's a little bit more challenging. So this is homework for you. Why don't you guys figure out what each of these terms means? Of course, this is not in your syllabus, but if you wanted to, you can look at it and you can say, well, this is basically saying if this particular check is false, then go to line 41, which is essentially out of this loop. And if the check is positive, then you skip this, you just move into this logic where you're summing n to sum, and then you go to line 28 and you keep doing this process over and over again. So which is essentially the same thing as we had here, but in language that is a little bit harder to understand. So a low-level language has a form that is closer to what the machine's hardware understands, and a high-level language, it has a form that is closer to what humans understand, and this is what C, C++, Java, Python, etc. do for us. So this is the basic distinction between low-level and high-level languages.